Okay, so chapter 9. We're gonna start. This is a very financial chapter. We're gonna talk about interest, compound interest, mortgages, annuities, lots of things that'll probably happen in your lifetime at some point. Things that you'll have to deal with. Now, normally, you know, you could just trust a bank or I guess maybe somebody you hire to explain all this to you. But you're better off if you know a little bit about it yourself. So chapter 9 is kind of that chapter we're going to talk about and give you some, background knowledge as to how all this stuff works, how you're going to be buying homes in the future, how you can save up money for retirement or uh, other savings accounts, maybe for your, children's college education or whatever in the long run. But anyway, it's a very interesting chapter. Some of it you might know a little bit of. I don't know. You might know a little bit about compound interest already. But there's a lot of things I'm sure that'll be new. So interest. If you borrow money, you should expect to pay a fee to do so. And if you lend money, you should expect to receive a fee. So basically, it's kind of like operating a business. You're giving people, this is how banks work essentially, right? If you get a loan from a bank, the bank is offering a service. They're giving you money with the promise that you'll pay that money back plus a fee, right? Interest. So that's how the bank makes money. They make it a lot of different ways, but that's one way, right? They lend you money and they expect that you repay it, and you repay it with interest. So the money, so the bank actually makes something off of you. And if you don't pay it back, your credit score goes down and you can't buy anything ever for the rest of your life, sort of. So interest is describing that fee that you're paying or receiving. So if you lend your friend $1 to go get a snack from the vending machine, then you can tell them that they can repay you tomorrow. Well, make sure you charge them interest. Okay, make them pay you $1.10 or something. So because you were generous enough to loan your money, and money ain't free, so they got to pay for a little bit for it. The interest rate is the percentage obtained by expressing the amount of interest as a percentage of the amount of money used. Interest rate is expressed as a percentage per unit of time. Also, any transaction involving borrowing money, the amount borrowed is called the principal. And yes, that is how it's spelled in the financial world. I understand that's the same. I think that's the same spelling for principal, like a school or something. But yeah, it's spelled that way. So don't question my English there. Okay, you can Google it. Example 1: find the interest on a loan of $1,000, given that the interest rate is 9% per year and the term of the loan is 6 months. So, interest. So what interest is it's going to take I is for interest. It's going to take the amount you start with, the principal. You're going to multiply it by its rate, which is the percent that percent of interest, the percent of that money that you'll have to pay back, and then times time, however how long you keep it. Obviously, the longer you borrow the money, the more interest you'll have to pay. So time has to be considered a factor. So this is the interest formula, essentially. It's very simple. You take the principal, which in this case is $1,000. You multiply it by the rate. Now, rate is 9%, but as a value for us, 9% is 0.09. So you do have to make sure you convert your percentages to decimals. And then T is time. Now, T is usually time in years, but we're talking about 6 months. 6 months is half a year. So we're going to multiply it by, I guess we can just use parentheses, right? Multiply it by 0.5, because that's half. So there you go. There's your interest formula. Calculate this, and I believe it's $45. So $45 is the interest or the fee for borrowing this money. So at the end, if you borrow this $1,000, you're going to be expected to pay $1,000 plus $45, so $1,045 in return for borrowing that money. Example 2, a farmer has an opportunity to lease an additional field to plant a larger soybean crop. The lease of the land will cost $6,000, which must be paid in advance, seed, fertilizer, herbicide, and other costs associated with planting the additional field will amount to $9,000. The farmer estimates that he can sell the crop for $17,800. The farmer has no excess cash, and he will need to borrow for 8 months the $15,000 necessary to produce the crop. What interest rate per year can he afford to pay and still make a profit of at least $1,000? So there's a lot of information in this problem. Now, the first thing I'm going to point out is the costs. He needs $6,000 to buy more land for his crops, and then he needs another $9,000 to support those crops, to fertilize them, all that stuff. So $6,000 for the land, $9,000 for the crops, which brings the total up to the $15,000 that we're referring to here. So he needs $15,000 to make this expansion on his farm. Now, he thinks that once that expansion is done and he's grown all his crops, that he can sell those crops for $17,800, which means $17,800 minus the $15,000 he paid to make the expansion, right? So he's predicting he's going to make this much money, and we know this is the cost, right? So in theory, that's a profit of $2,800. Now the thing is, that's not going to be his profit, because for the $15,000 he borrows, he's going to have to pay interest on. So if we think about it like this, he's going to get a $15,000 loan, and he's going to have to pay some amount of interest on that loan. And that's our goal, to figure out what percentage it will be. Now, he still wants to make $1,000 of profit. So if this is his theoretically like free, like if he didn't have any interest charged to him, he would make $2,800 in profit. Well, if we want at least $1,000 of profit, then that means we don't want to exceed interest of more than $1,800, because $2,800 is his theoretical profit. However, we know that that's not going to be the case, because we know some of that money is going to get paid in interest. So if we set aside $1,000 as a pure profit, then that means, we're budgeting essentially $1,800 for pure interest. So we don't want, we have to borrow $15,000, and we don't want to max any more than $1,800 in interest, because we still want to make at least $1,000 in profit. Together, that totals up to that $17,800. So this is the profit we want. At least, it could be more, but it can't be less. We want at least $1,000 profit, so that sets us up with no more than $1,800 in interest. Hopefully that makes sense. So we know that our cap on interest is $1,800. Interest equals P times R times T. Our interest cap is $1,800. Our principal, which is what we're being loaned, we need to take out a loan of $15,000 times the rate, which is what we're trying to figure out. We're trying to figure out what interest rate can we afford. And we know we're borrowing this money for 8 months. So remember, time is in years. So 8 months is 8 twelfths of a year, which is 2/3, but I'm just going to write it as 8 over 12, just for the sake of being consistent with the whole time thing. Obviously, for one whole year, it'd be 12 out of 12, which is just 1, but we're only going for 8 months. So 8 out of 12, 8 twelfths of a year. So that's our equation. We just need to simply solve this for R. What I would probably do is, I'm obviously, all these are just being multiplied together. So I would just multiply this value with this value. So I can just combine them into one. So 15,000 times 8 twelfths is actually going to be 10,000. So if you combine those numbers, you have 1,800 equals 10,000 times R. So if you're wondering where I'm getting 10,000 from, it's this 15,000 times 8 twelfths. That combines to make the 10,000. And now, of course, you want to solve for r, then you would divide both sides by 10,000. So you would have the 1,800 divided by 10,000, and that will tell you your rate, which comes out to be 0.18 or 18%. So if we're going to the bank to take out this loan, we want to make sure that our interest rate is not any higher than 18%. If our interest rate is higher than 18%, then we will not make the $1,000 profit that we want. If it's less than 18%, then that's good, because then our profit can be more than $1,000. But 18% is our max interest rate that we would want, so that we can still make $1,000 in profit from these crops. You might need to watch that example again, because there is a lot of information going on. Simple interest versus compound interest. So simple interest is this. It's interest paid only on the original amount and any new deposits you put in the account, but not on any accumulated interest. So let's say you put $1,000 in an account and you earn 10% interest. Well, if you earn 10% interest, then you would make 10% of this, which is what, $100? So interest would pay $100 into the bank account. So now your bank account is $1,100. But the next time they go to pay you interest, they're only still going to pay you 10% on the original amount. They're not going to take account the fact that you have $1,100 in the bank anymore. They're only going to take into account the $1,000. They're not going to give you interest on the money they gave you. So basically, every single time they pay you interest, it's always going to be $100, because 10% of 1,000 is always going to be $100. Compound interest, which is the difference, the next one, which is a more common one, is where they would pay you the interest on this $1,100. So you put $1,000 in the bank gives you the 10% interest, which is $100, and so now your account is $1,100. And on the next month, they charge you, or they give you 10% of the $1,100. So 10% of that would be like, I don't know, $110. So then the next month, they're giving you $110 in your account, not $100. So they're giving you more money for essentially leaving the money they gave you in your bank account. They're giving you interest on top of interest. They're not just going to take 10% of this original amount. They're going to take 10% of everything in your bank account, including the money that they paid you already in interest. So you're earning interest on interest, if that makes sense. It's compounded for a reason. It's called compound interest because of that exact reason. You're getting interest on interest. The money the bank pays you for having money in their bank, and then they pay you essentially for leaving that money in the bank. So it builds over time. The longer you leave it in there, the more interest you're going to make each month, or however many times they compound it, and you get more and more money every time, which is kind of nice. Simple interest is not so much, because they're only going to pay you 10% of the $1,000, the original amount every time, and they're not going to give you 10% of any additional money that is put into your account. So the compound interest formula is this. Now, P of N is kind of just like the answer. You might sometimes see this as A. So don't worry too much about that. P stands for principal, which again is our starting amount. K is our interest rate per unit of time. That's going to be very important because it's going to be a little bit of a mini math problem to get the K value. Same thing with N. N is the number of times compounded, which can also be sort of like a mini math problem for us. But this is the formula. I will stress, though, that K and N are very important values because they're going to be in pretty much every formula we use in this chapter. There's going to be a lot of formulas in this chapter, which makes it kind of easy, but also makes it kind of hard because, of course, you got to be very accurate with how you set up your formula and very accurate with how you type it in your calculator. So I'm going to stress K and N a lot on our first example so that we make sure we get that down because it's going to show up a lot in this chapter. So example 3, the Fourth Federal Bank of Mulberry offers a savings account in which interest is paid at a rate of 4% per year. compounded quarterly, and automatically credited to the account. At the end of each quarter, the interest is computed by using as the principal the minimum amount in the account during the quarter. Assuming no deposits or withdrawals, the amount on deposit at the beginning of each quarter consists of the original amount deposited into the account plus all the interest credited to the account. All this stuff right here, basically from this point to this point, is just mumbo jumbo to explain, hey, we have a compound interest account. This person's going to put money in it. They're going to earn interest on it, and they're going to earn interest on that interest that they leave in there. You're not going to make any extra deposits. They're just going to put money in the account and let it grow. So if that kind of went over your head, don't bother too much. It's not the most useful information. Again, it's just telling us it's a compound interest savings account. Jessica opens an account on July 1st into which she initially deposits $1,000. How much will be in the account after 5 years, assuming there are no deposits or withdrawals other than the interest being credited to the account to the bank? So we're using our compound interest formula because of this massive paragraph in the middle that says, hey, this is compound interest. So our compound interest formula is P 1 plus K to the n power. Of course, this equals the A value or the answer, but I'm just going to focus on setting this up. So principal's the amount that we're starting with. So Jessica here is depositing $1,000 in the bank. So $1,000 is the P value, is the principal. Then we have 1 plus K. Now here's where K gets interesting because K is our interest rate per unit of time. So we know our interest is 4%, but we're being compounded quarterly. So it's 4% quarterly. So how K is going to work is we're going to have to take both those into consideration. K is going to be that 4%, which 4% is 0.04, by the way, divided by 4 because it's 4% quarterly. So it's 4 times a year. So you're dividing it by 4 because you're cutting it up into fourths because you're doing it 4 times a year. So it's the percentage, which is 0.04, and then divided by how many times it's compounded. So this is the K value, which if you want to go ahead and evaluate that, that is the same as 0.01. So K is, like I said, a mini math problem inside a math problem because you're not just going to look at one thing. You're going to have to look at 2 things to figure that out. So be very careful on how you get K. We're going to have plenty of practice with it. So eventually over time, you'll really start to get the hang of it. Now, N, remember, is the number of times it's compounded. A number of times it's compounded. So it's compounded quarterly, which is 4 times a year. And it's doing that for 5 years. So if it's 4 times a year and it's done for 5 years, well, then that's going to be 20 times in total. So N is going to be 20 to represent that. So N, like I said, is also kind of a mini math problem and a math problem. N is a little easier than K, although they are very similar. So that's your compound interest formula, all plugged in. Now you would just type that in the calculator and get a value. And I'm just going to save that. I think you guys can type that in the calculator. You're pretty good with that. I think setting up the formula is really kind of slightly more important. So example 4, an amount of $1,000 is invested for 10 years and interest is compounded and added every 6 months at a rate of 5% per year. Find the total amount of interest added to the investment by the end of the 10th year. So again, we know we have a compound interest problem. So we're going to use our compound interest formula. So let's start with the principal. Principal is how much we're investing, which is $1,000. It's pretty straightforward. 1 plus K. So again, K is our interest rate per unit of time. So it's 5%, but it's being compounded every 6 months. So everything's relative to a year. So if our interest rate is 5%, which is 0.05, and it's compounded every 6 months, well, how many times is it compounded in a year? Well, that's going to be, if it's every 6 months, then it's twice a year. So it's very much a sort of math problem and a math problem. You have 5% compounded twice a year. So K is 0.05 divided by 2, which is 0.025. So that's your K value. And then N's a little easier, right? This is going to be done for 10 years. And again, if it's every 6 months, then it's twice a year. So 10 years, twice every year, that's going to be a total of 20 times. So N's going to be 20. So there's your formula. You plug it in, and you're good to go. Now that was the same thing as semi-annually, what we just found out here. So that was, let me go ahead and write it back in here. It was 1,001 plus 0.025 to the 20th power. Now, just to prove something here, if we think about the same problem, but instead of, that problem was compounded every 6 months, which was twice a year, which is called semi-annually. What if it was just done once a year, right? Just annually. Well, the formula for that would have been 1,000, then 1 plus, here's your K value, because remember K is the 5%. And if it's compounded once a year, then it's 5% divided by 1, which is just the 0.05. And if it's compounded once a year for 10 years, and it's compounded 10 times in total. So there's your formula there. I'm going to get the values for this in a second, but I want to at least give you these formulas. Let's think about the same problem if it was quarterly. Quarterly means 4 times a year. So we'd have $1,000 as the principal, 1 plus. Now the K value for this would be the 5% divided by 4, which 0.0125, I think, but let me double check that. Yeah, 0.0125, 0.0125. And if it's compounded 4 times a year for 10 years, then it's compounded 40 times. So it'd be to the 40th power. And then lastly, if it was done monthly, you'd have 1 plus, again, so the K value was our interest rate divided by how many times compounded a year, which would be 12 times a year if it was monthly. And that would be 0.05 divided by 12. 0.0041. 0.0041. We'll say 7. Round it a little bit. And then monthly is 12 times a year. And again, this is an investment for 10 years. So that would be 120 times compounded. Now, the thing I'm showing you is these formulas all look very different, right? But there's 2 things that are consistent here. The principal, we're always starting with $1,000, and the interest rate, 5%. Well, I guess 3 things, 10 years as well. So it's $1,000, 5% interest for 10 years. So let's see how big a difference the number of times it's compounded in a year really makes. So if you plug these in the calculator and get the values for them, you would have, let me get the piece of paper that has them. If it was done annually, it would be $1,790.85. The semi-annually results in $1,806.11. Quarterly is $1,814.02. And then if it was monthly, it was $1,819.40. So all in all, it's really not that big a difference. It's a bigger difference between annually and semi-annually than it is quarterly and monthly. I mean, you go from 4 times a year to 12 times a year, and the only difference after 10 years is about $5, right? 1814 to 1819 is like $5. So in the grand scheme of things, the number of times it's compounded in a year really isn't going to make that big of an impact, because after 10 years, I mean, these are still very similar numbers. Yeah, they're different, but ultimately it's not that big a difference. Not in the grand scheme of things anyway. So the most important thing, of course, is principal, interest rate, and time. The number of times it's compounded in a year makes a very small impact. It doesn't really affect the end results too much. So I wanted to at least show you that. So now let's talk about annual percentage yield. So let me try to explain this. It's kind of confusing to explain, but I think the book said it pretty well when it writes this. If interest is compounded and paid at time intervals other than once a year, what interest rate or what rate of interest compounded and paid once a year gives the same return? So what this kind of means is, you know how we get like, if we do it monthly, we compound something monthly, we get a certain result at the end of the year. So let's say you invest $800, right? You some interest rate, yada yada, compounded monthly, and at the end of the year you ended up with $915. So what annual percentage yield is let's assume we only did it once a year. We compounded once a year. What interest rate would that have been and still end up at the $915 result? So it's basically like ignoring the whole how many times you compound it in a year, and it's just like converting it into what is that percentage as a whole year. Just if you were to just do one time compounding at the end of the year and end up with the same result, what's that percentage yield? So that's why it's, I guess, the name annual percentage yield, because it's taking something, the interest rate that would be compounded more than once, converting it into a percentage that would be equivalent if you were only going to do it once in a year. If that makes sense. And this is the formula. Now, it looks kind of confusing. I get that. But at the end of the day, it's a formula. So formulas are nice. We like them. So our annual percentage yields is 100 times A divided by P. So A, did I write this down on the next slide? No, I did not. Okay. Well, let's just get into the example, and we'll try to explain all those different values in that example. So find the annual percentage yield for an account in which interest is compounded quarterly at a rate of 6% per year. So notice how this problem doesn't really give us a principal value. It doesn't tell us how much money we put into the account, because that's technically going to be irrelevant. It's not going to make a difference because we're trying to find a percentage on our interest rate. And the percentage would be the same no matter what the amount of money we put in the bank account is. So with that in mind, let's use the formulas we've been using. Let's use it as one. Let's say, hey, what if we just, what if we're just depositing $1 in the bank account? That way we can do the math a little easier. So here's how we're going to do this. Our A value is sort of, I guess, the amount at the end of the year, right? So let's pretend, and you can use anything you want for this, okay? But we're using our compound interest formula, because remember I told you it could be A that equals this, but originally I said P of N, but we're going to go back to the whole A thing because it's relevant to this formula. P1 plus K to the N power. So here, again, it doesn't give us a principal, so we can make any number we want for P. I'm going to use the number 1, simply because it's going to be super easy and convenient to use. So let's just say, hey, I deposit $1, right? 1 plus K. So K we get from this information, 6% per year compounded quarterly. So that would be 0.06 divided by 4. And if we do that, again, let me get the calculator, 0.06 divided by 4, isn't it 0.015? Yeah, 0.015. So K is 0.015. And then to the N power. So if it's compounded for 1 year, 4 times a year, then it's compounding 4 times. So this will be our A value. So basically, if we deposit $1, right, at the beginning of the year as our principal, then at the end of the year, we would have $1.06. I'm going to go a few decimal places out here. to be really accurate later on. So again, it doesn't really matter what you use for P, okay? But I'm using 1 because I figured it was going to be convenient. But when we look at our formula, let me go back to this. Our formula A divided by P, 1 over T. Is it plus 1 or minus 1? It's minus 1. This is the formula from the last slide right here. Okay. A is your amount after 1 year. P is your principal, what you're putting in, right? And I think T is pretty self-explanatory. T is like the time, but it's relative to. No, it's not relative to the time. It's just relative. It's just relative to how many years. So if we use the formula, this is the value I'm going to use for A because that's the amount of money I would have after 1 year in theory, right? So we would have 100. I'm plugging the numbers in here. So it would be 1.06136 divided by P. Remember, P is the principal, and I said that in this case, I was just going to use 1 as principal. So it's going to be over 1. And that's going to be, gosh, it's really hard to make sure I can fit this in parentheses. There you go, 1 over T. So we're doing this for just 1 year, so it's 1 over 1. And then minus 1 at the end. So I plugged in 3 numbers, okay? I plugged in the A value. Well, I picked a P value because it didn't give me a principal. So again, I picked 1. So that's the same thing as the P value in the formula. I just picked it. I could have picked 100, and I could have used 100 here, and I could have used 100 here. It wouldn't have made a difference at the end of this problem. But I picked 1 because I figured it'd be the easiest one to work with. And I got the value for A using that. So that's using the compound interest formula. And then I know T because this is only going to be done. I'm only looking for it after 1 year. So if I plug this in the calculator, I get, wait for it, 6.136. And this is my percentage yield. So I know I'm rambling, but let me backtrack to kind of explain now what this answer actually means. So this account, right, is 6% per year, compounded quarterly. But at the end of the year, our interest rate wasn't really 6%, because at the end of the year, I would have made enough money that's really worth 6.136%, right? Because if I put $1 in the bank account, and at the end of 1 year, I get $1.06 and then 1.136, whatever, I'm actually made a little bit more than the 6%, because obviously 6% of $1 would just be 6 cents. So my annual percentage yield is sort of like my actual interest rate, if you will, my actual yearly interest rate. I made more than 6% after 1 year. I made 6.136%, which is a little more. It's not going to be that different. Granted, because if you look back over here on these values, you can see that they were not that different because the percentage overall is really not that different. The annual percentage yield for those problems would not be that different. But that's what it is. It's sort of your end of year percent increase, if you will, and not just your percentage when it's being compounded. So let's try this again now that we've explained it. Let's try to see if we can do it with example 6. Now we actually have a real principal. A $10,000 6-month certificate of deposit pays interest at a rate of 4% per year, 4.8% per year. What is the annual percentage yield? So again, our formula was 100. It's going to be A divided by P, and then that's to the 1 over T power, minus 1. And so now we're going to plug these things in. So first, let's find out what A is. So A is going to be equal to the 1 or $10,000 and the 1 plus K. So K in this case, K would be the 4%, 4.8%, which is oh crap, come on, which would be 0.048, and it's doing 6-month certificates, so that would be obviously twice a year. So we're going to divide it by 2 if it was done in 6 months. 0.048 divided by 2. Now, here's a weird part, okay? Now, you're going to hate me for this, and I hope I don't confuse you too much. But this is only 6-month certificate. It's not actually going for a whole year. We're only finding the value after 6 months. So we're only going to compound it one time in that 6 months. We're not actually going to compound it in 6 months and then again after a year. So I know that's confusing, but this is only for 6 months, and it's only being compounded once in that amount of time, so the end value is 1 there. And I wrote 1,000 instead of 10,000, so I'm terrible. But hold on. Yeah, okay, just making sure. So if you calculate that, then the A value comes out to 10,240. So that's what I'm going to plug into this equation. So 1,240. Because essentially what the A value is how much money we have at the end of this term. So if we deposit $10,000, then in 6 months, when my certificate runs out, I will have $10,240. So A is, like I said, your final amount. Okay. Either at the end of the term or after 1 year. This didn't go for a whole year, so we did it after its term, which is only 6 months. 10,240. Now divided by P. P was our principal. So again, we have the $10,000 principal here. Okay. So now 1 over T. This is 1 over, again, we're not doing this for a whole year. We're only doing this for half a year. So T is only half a year. So T is 0.5. Okay. And then minus 1. And if you simplify this, you break it down a little bit, you plug it in the calculator, bada bing, bada boom, some magic happens. We get 4.86% as a value. So again, that's interesting because my interest rate was 4.8%, but the amount of money that I'm going to get at the end of 1 year, if I were to do this for a full year, because again, this is called annual percentage yield, so it's considering the fact that it'd be at the end of the year, which obviously doesn't exist in this problem, but still finding that percentage yield. After 1 year, I would have gotten 4.86% interest, not 4.8% interest. So like I said, it's not going to be too different, but so it should be kind of close. Should be a little more normally as well. Okay. So Steve has an account in a money market mutual fund that pays interest daily at a rate which usually changes from day to day. In a quarter during which he makes no deposits or withdrawals, his account increases from $6,754.85 to $6,842. Find the annual percentage yield for this period. Okay. So straight using the formula here, 100 A divided by P, 1 over T minus 1. Now, A is the amount after 1 year, or the amount after the term, which it tells us here is 6,842. P is the principal, what he starts with, which it tells us here. So those two values go straight into this formula. We have 100. We have our A value, which is $6,842, divided by the P value, which is $6,754.85. And that's 1 over T. And what does this problem say? Interesting. Makes no deposit or withdrawals. Annual percentage yield. Okay, so if it's done in a quarter, then again, don't get this confused here. I know you want to put 4, but it's not 4. If you put 4 in for T, that means for 4 years. But we're not doing it 4 years. We're doing it every quarter, which is 1/4 of a year. So t is 1/4 of a year, which you can write as 1/4 if you want to. So it'd be technically 1/1/4. Or, you can say it's 0.25 if that makes you feel any better. I hope. I know that's confusing. It's really weird at first. It's kind of backwards from what you're thinking. But this is how often in a year it is. 1/4 is 1/4 of a year. Remember, t is relative to a year. 6 months was half. That's why we put 0.5 in an earlier example. But in this problem, we're doing 1/4 of a year, which is 0.25. So it'd be 1/0.25, which if you want to simplify that, you can, because 1 divided by 0.25 is 4. So technically that whole thing ends up being 4. I know that can be a bit of a stretch, but that's somewhat of the explanation to what the t value would be. And then you've got that. I think that was the hardest part of this problem, is not putting 4 in for t, but putting in 1/4 in for t, or 0.25. So if you calculate this all out, you end up with 5.26% as your annual percentage yield. Interesting stuff overall. That's going to be it for this video. I know it's confusing at first. It definitely gets easier once you just get some problems and you look through some of these numbers yourself and you just practice them. I spent more of this video trying to explain what things were rather than how to do it. Doing it's not going to be that difficult. I just really wanted you guys to know like what it all was. So I'll see you guys in the next section. Okay, later.